So, the next distribution in the list of absolutely continuous distributions is the beta distribution. So, before I introduce beta distribution, let me introduce beta function. So, a beta function is a function of two positive real numbers defined on 0 infinity cross 0 to infinity, and it takes value in 0 to infinity, and it is defined by beta a b as 0 to 1 t to power a minus 1 minus t to power b minus 1 dt. Now, one can show that this integral is finite for every a positive and for every b positive. So, this integral is finite for every a positive. So, that means your beta function, which is a function of two variables a and b, makes sense for any a positive and any b positive. Now, one can show that beta a b turns out to be gamma a multiplied by gamma b divided by gamma of a plus b. I give this as an exercise to you. I can give you a hint. What you do is you consider gamma a into gamma b. This will be 0 to infinity e to power minus s to power a minus 1 ds multiplied by 0 to infinity e to power minus t to power b minus 1 dt. Now, you combine this becomes 0 to infinity e to power minus s plus t s to power a minus 1 t to power b minus 1 ds dt. Now, what you do is you make the transformation x is equal to s upon s plus t and y is equal to s plus t. So, that means your s turns out to be xy, t turns out to be y minus xy. So, that means y times 1 minus x. So, if one has to look at the Jacobian, del s by del x which is phi, del s by del y which is x, del t by del x which is minus phi, del t by del y which is 1 minus x. So, this turns out to be y minus xy plus xy. So, this turns out to be y. And let us look at the range. S is positive, t is positive. So, that means xy is positive and y into 1 minus x is positive. So, this would give x is between 0 and 1 and y is greater than 0. So, that is why this gamma a into gamma b will turn out to be x from 0 to 1. This is the range for 1, x, y from 0 to infinity. Jacobian researched out on the first of Jacobian term, mod of y, but y is positive. So, mod of y would be y. Then e to power minus s plus t. S plus t you can see is xy plus so e to power minus y. S to power a minus 1. So, xy to power a minus 1. T to power b minus 1. So, y into 1 minus x to power b minus 1 dy. So, you can see you can certainly separate out the terms of x and y. So, this turns out to be 0 to 1, x to power a minus 1, x to power a plus b minus 1, y to power b minus 1, x to power a minus 1, y to power b minus 1, sorry, x to power a minus 1, sorry, let me just, so this is same as 0 to 1, x to power a minus 1, 1 minus x to power b minus 1, then 0 to infinity, e to power minus y, y to power a plus b minus 1. Now, this is nothing but gamma of a plus b. So, that means gamma a, gamma b upon gamma a plus b is nothing but 0 to a 1 x to power a minus 1, 1 minus x to power b minus 1, which is nothing but beta a b. So, from this I can construct a PDF. So, I say a random variable x is said to have a gamma beta distribution with parameter a greater than 0 and b greater than 0, written as x having beta a b if its PDF is given by fxx, which is 1 upon beta a b, x to power a minus 1, 1 minus x to power b minus 1, if x is between 0 to 1 and 0 otherwise. Note that over here, if I take a as 1, b is 1, then it becomes, density becomes common over 0, 1. So, that constant, that means has to be 1. So, that means 1 upon beta 1, 1 has to be 1. So, that means if I take a is equal to 1 and b is equal to 1, I get the uniform distribution. So, note that beta 1, 1 distribution is nothing but uniform 0, 1 distribution. Let us try to see its movement. So, suppose x has beta a b distribution, then for r greater than minus a, expected of x to power r is 1 upon beta to ab, x to power r, then the density which is x to power a minus 1, 1 minus x to power b minus 1 divided by beta ab. So this turns out to be 1 upon beta ab, 0 to 1, x to power a plus r minus 1, 1 minus x to power b minus 1 dx. Now for this integral to be finite, I know that a plus r has to be positive and b has to be positive. So that means r has to be greater than minus a. If r is greater than minus a, this is a beta integral, and its value is nothing but beta a plus r b divided by beta a b. And one can use the formula of beta a plus r b, gamma a plus r, gamma b will come from here also, so that gets cancelled. Then gamma a plus b comes from the denominator, then gamma a plus b plus r. So this is how one can get the expected value of x to power r. So mean, which is obtained by putting r is equal to 1, is a upon a plus b. Expected of x square is by putting r is equal to 2, one can see is a plus 1 upon a plus b into a plus b plus 1. Variance, which is expected of x square minus expected of x whole square, turns out to be this quantity. It's easy to verify. Now one thing one has to note that beta a distribution. So if x is beta a, that means its PDF is 1 upon beta a, x to power a minus 1, 1 minus x to power a minus 1, if x is between 0 to 1. So it looks like by looking at the form of fx, if I look at the PDF on the right hand side of a point half, that should be mirror image of PDF on the left hand side of the half, and that is what is happening. If I look at fx half minus x, which is same as fx plus half, which is 1 upon beta a, half minus x to power a minus 1, half plus x to power a minus 1, if x is between minus half to half and 0 otherwise. It's just straightforward. So what it suggests is if both the parameters of beta distribution are the same, then its distribution is symmetric about the point half. So that means if x is beta a, then its distribution is symmetric about point half. So in particular, since all movements exist, mean will be half, median would be half. Let us try to see what is its movement generating function. If x is beta ab, then mxt is this, which is same as 0 to 1, because that is where the density is positive for x, e to power tx. The density of x, which is 1 upon beta ab, x to power a minus 1, 1 minus x to power b minus 1 dx. So one can expand this as 0 to 1, summation r is equal to 0 to infinity, dx to power r by factorial r, x to power a minus 1, 1 minus x to power b minus 1. So this one takes outside, so summation r is equal to 0 to infinity comes outside, beta ab, t to power r by factorial r comes out, then 0 to 1 x to power a plus r minus 1, 1 minus x to power beta. So that becomes summation r is equal to 0 to infinity, beta a plus r b by beta ab t to power r by factorial r. If you simplify this, this turns out to be this quantity. So this was all about the beta distribution.